Hi everyone. Today we're going to be looking at graphing linear equations, particularly with a focus on finding where they intersect with other linear equations, okay? So even though we know that we can solve the above just by using our normal algebra, I really want you to see how we can visualize it, and it really helps out with worded problems and then other sorts of graphs later on that are a bit harder to solve. So the easiest way to go about this is to kind of pick what's going to be graph 1 and what's going to be graph 2. Okay, now in this situation, I've got two graphs. They're both y equals something, okay, because we imagine that this is y equals, and so is the one on the right. So my first graph, or graph number 1, is going to be y equals 4x minus 7. I know that my y-intercept for this one is 0, -7, so I'm going to mark that out there. And I know that my gradient is 4. So for every one that I go across, I'm going to be going up 4. Okay, once I have my 2 points, I am just going to draw my line through those. Okay. Now, obviously try and make sure your graph doesn't quite curve like that. Our next equation here is going to be y equals 5. Now remember, this one has a 0 gradient, and it just means that no matter what happens to the x, the y is always 5. So we're going to be going across here where y equals 5 on our graph. Now what you want to be doing to solve this just by looking at it is to find this intersection point here. That's where they're crossing, that is where they're equal, and there's no other point on the graph that they're going to be equal because they're only going to cross past each other once. This point here, we've gone 3 across from the origin and we've gone 5 up. Now, if we want to verify that, we do just sub that into our equation, and if I sub in x equals 5, I should end up, x equals 3, I should end up with this being correct, which we know that 12 minus 7 is 5. So we know that that is correct, and that is where they're going to intersect. Now, same idea here. We're going to be drawing these two graphs. Feel free to pause the video if you'd like. But when you're solving, you are solving for both x and y. So I'm once again going to be doing these in 2 different colors. Obviously, you don't have to though, but that is what I will be doing. Now, if I go to sketch this graph on the left, I've got y equals 3x minus 5. So I know that my intercept here is going to be at 0, -5, and that because my m is 3, or 3/1, for every one across, I'm going to go up 3. And I'm going to try and connect those in a nice straight line. So that there is my graph 1. I'm now going to draw out my second graph, which is 2x minus 1. So I know that my y-intercept will happen at 0, -1. So I'm going to label that one there. And that my m is 2. So for every one across I go, I'm going to go 2 up. If I connect those 2 dots up, I should hopefully cross our line. Okay. Now, sometimes it's not overly accurate when you cross, but if I have a look at where they've intersected at about here. Now, that doesn't look too good on our end of things, okay? But hopefully if we did this accurately, it would be a bit better. Now, what I'm seeing here is that it's just below 4 and it's just over 5. So I'm going to call that 4, 5 for now and see if that fits in with the above. If I sub in 4 into my 3x minus 5, hopefully I end up with the same over here. And by the looks of it, I do, because I end up with 12 minus 5 and 8 minus 1, which gives me 7. Okay? So that's not meant to be 4, 5. It should actually be 4, 7. So hopefully you've graphed that one a bit more accurately than me. Now, graphing these sorts of things are also quite helpful when it comes to worded problems. And when it comes to worded problems, it's best to figure out your formula first or your equation for this line. Now, when we do have a worded problem, we like to look for the constant term, which is usually like a call out fee or just something that they charge you, and then the rate of change, which is usually like an hourly rate of some kind. What that means, for this one at least, is that plumber 1, his C value is $30, his constant value, and his M is 35. If I let H be the number of hours he works, or X, I should end up with Y being my cost is equal to 35X plus 30. Now, for my second plumber, he's just charging $45 per hour. He's not charging a call-out fee or a fee for the system. So that means my second plumber is just going to be 45X. So let's see how this plays out on a nice graph here. Once you plot the first one out, we should end up with this here. Now, keep in mind when you do a real life situation, you don't really go into the negatives because we can't really make the plumber pay for work that he's come out to do. Once you plot the second graph, you're going to end up here. Now, this one should go through 0, 0 because he's not charging anything when he first gets there. He's just charging you per hour, remembering that this axis here is our number of hours. If we look closely at where these two have intersected, they've intersected at x equals 3 and y equals 135. What that means is that these two are charging the same at 3 hours. They're both charging $135 at 3 hours. And sometimes this is a little bit easier to do than to solve by hand, but it's a lot more handy when it comes to things like quadratics and further functions which have more than one intersection point.